Here's another example of multiplying two functions within the context of the same situation that we just discussed. If delta t is the time it takes the ball to reach the ground after going off of the end of the ramp, and h is the height of the raised end of the ramp above the table, then delta t is obviously going to go down in some fashion. I'm not even sure the graph has this shape. I'd have to look at the function and think about it a little more than I have time to right now. Although it wouldn't be difficult, you just solve the quadratic equation, look at the function, and see what the graph looks like. We're going to assume that the ramp is high enough that delta t starts out when h is equal to 0 over 1 second. Now, as we raise the end of the ramp, the ball has a greater and greater downward velocity, and the delta t will fall, and let's say it falls down below 1 unit of time, 1 second. Let's use now the v0x function from the previous example that goes from 0 up to a maximum and then down to 0 when h equals L. If we multiply the v0x function by the delta t function, we get the range function delta x of h, v0x times delta t. So with that in mind, we're going to multiply this graph by this graph. The first thing we notice is that this graph here is 0 at 2 points. And if one graph or the other is 0, then the product of the two functions is going to be 0. And we therefore put big red dots on these points to indicate that the product function x of h, or delta x of h, is going to be 0 here and here. Another thing we look for is the point or points where one function or another is equal to 1. Okay? Now the delta t is equal to 1 here. It just happens to be where the two graphs cross. That was an unintentional accident, and it's not a very good idea. The fact that I've put this point here has nothing to do with the fact that the two graphs cross here. It's simply that at this point delta t equals 1, so that v0x delta t just equals v0x, so that the product of the two functions will just be equal to the v0x function, and we're going to put a big red dot here. Then we come over here, our delta t is falling below 1. At this point we say maybe delta t is about 0.7. So we're going to have a graph that's 0.7 as high as the v0x graph. And that's what we see here. That's this point. Now, with those points we can get a pretty good idea what the product graph looks like. We've illustrated a couple of important ideas here. And actually there are a couple more things we want to point out. Between here and here, delta t is greater than 1, so that we're going to multiply v0x by a number greater than 1. That's going to give us a set of points that are higher than the v0x graph. From here to here, v0x is less than 1, so the graph points are going to be less and less than the v0x points. Another thing is, in this region here, v0x seems to kind of level out around 1/2. So that the product function here is going to be about 1/2 of the v0x function, and it's going to approach this point here, where the point L0, with a slope that's about half that of the v0x function. Now the basic principles are we look for the points where one function or another is 0, because that makes the product 0. We look for the points where one function or another is equal to 1. Here's a point where the delta t function is 1. The v0 function, v0x function, is on a different scale than the delta t function, and we're assuming it doesn't have a 1 on this graph. It won't necessarily be 1 at the same level where delta t is 1. But we find that point, and that gives us, when one function is equal to 1, the product will be equal to the other function. And we make a few more common sense observations, and we obtain a pretty good idea of how to put these two graphs together.